Welcome to The Explainer, where we decode the future. Today, we're not just looking at a new phone, we're looking at a new kind of partner for, well, humanity's next giant leap. This is the Helios X1, a concept designed for the harsh realities of Mars.
All right, let's just jump right in with a question. If you were packing for a trip to another planet, would you bring your phone? It sounds so simple, right? But the answer really shows you just how unprepared our everyday tech is for that final frontier.
And yeah, the answer is a hard no. On the left, you've got a device designed for our nice, comfortable world. On the right, you have a machine built for an alien planet. We're talking about a device that has to survive a temperature swing from a pleasant 20 degrees Celsius all the way down to a bone-chilling minus 125, all while getting absolutely blasted by cosmic radiation.
So let's get into the nitty-gritty. What are the real challenges here? You know, the core problem, the real head-scratcher, is designing one single device that can function in two completely different and equally unforgiving environments. Because Mars isn't just cold, it's a gauntlet of silent killers for any standard piece of electronics. Think about it. There's basically no atmosphere, so you have no air to cool anything down. There's constant radiation that just fries circuits. And that dust, it's not just dirt. It's abrasive, it's electrostatically charged. It's just looking for something to clog up and short out.
And this, right here, this is the core engineering paradox. It's a real brain twister. On Earth, you're trying to keep water out but let air in for cooling. Simple enough. But on Mars, you need to radiate heat away into a vacuum, but at the same time insulate everything so it doesn't freeze solid overnight. I mean, they're complete opposites.
So how in the world do you solve a problem like that? Well, you start by building a shell. But this isn't just any shell. It has to be a multifunctional shield.
And the solution? It really does start with a material that sounds like it's straight out of science fiction: hydrated boron nitride nanotubes, or HBNNT. This isn't aluminum or titanium. This is a huge leap into advanced nanomaterials.
I mean, just think of it like a structural force field. It's way stronger than steel, sure, but its real magic? That's in how the hydrogen and boron atoms basically scatter and absorb all that nasty cosmic radiation. It's like solving two huge problems with one super elegant material.
Okay, so the body is tough, but what about the screen? You got to protect the face of this thing. So you replace that fragile glass screen we've all probably cracked with something you'd find on a military vehicle.
So yeah, this isn't glass. It's literally transparent armor. ALON is harder than sapphire, so it can resist that abrasive Martian bust. And get this, because it's transparent to a huge range of light, all the sensors can sit behind the screen. No more ugly notches or punch holes. How cool is that?
Right, so we've got this super tough body, but a strong body is nothing without a revolutionary mind to go with it. So how does the Helios X1 actually think and talk across millions and millions of miles of space? You know, to talk to satellites, you can't just slap a big, clunky dish on it. Instead, the Helios X1 uses something absolutely incredible: a thin printed surface that creates a holographic pattern to steer a satellite beam electronically. It's a super powerful antenna that's basically just another layer in the device itself. No moving parts. Wild.
But here's the catch. Even with a perfect connection, you just can't beat the speed of light. The time it takes for a signal to go from Mars to Earth and back again, we're talking anywhere from 4 minutes to 24 minutes. That makes a real-time chat with mission control totally impossible.
So the solution is brilliant. It's a split-brain AI. You've got a fast, reflexive AI right there on the device for the immediate life or death stuff, spotting a hazard. At the exact same time, the more complex, cognitive questions, those get beamed to Earth with the understanding that, hey, the answer's going to take a few minutes to get back.
All right, let's talk about the final pieces of this puzzle. How do you power this thing through a Martian night where temperatures can plummet to minus 125 Celsius? And maybe even trickier, how does an astronaut in a big, bulky spacesuit actually use it?
Yeah, your standard phone battery, it would freeze solid, instantly useless. So the Helios X1 needs a solid-state battery. By using a solid electrolyte instead of a liquid, it can not only work in that deep Martian cold, but it can also pack in way more energy. It's a win-win. And to handle those crazy temperature swings, its back is coated in what's essentially a smart skin. This stuff is amazing. It passively changes its properties. When it's freezing, it traps heat like a thermos. But when the processor starts working hard and gets hot, it just opens up and breathes that waste heat out into space.
And this slide, this just brilliantly shows the interface solution.
I mean, forget trying to swipe a touchscreen with a thick, pressurized glove. It's not going to happen. Instead, this device can feel deliberate pressure, giving you a little haptic click so you know you pressed it. And even better, it uses ultrasonic sensors to track your hand gestures in midair. You don't even have to touch it.
Okay, so we've seen all the amazing tech, but what does it all mean in practice? Let's see how the Helios X1 could totally change the game for explorers, not just on other planets, but in the harshest places right here on Earth. Imagine this, a scientist in Antarctica. It's freezing. They can't take their gloves off. With this, they can do complex data analysis right there on the ice. The onboard AI is like a real-time partner, guiding their research as they go.
On Mars, this thing becomes a literal lifesaver. That local reflexive AI gives you an instant warning. Hey, dust devil approaching, suggesting a shelter route while your deep thought question for mission control is still halfway to Earth.
And that right there, that's the really profound shift in thinking here. We're moving away from a passive screen that just shows you stuff to an active partner that helps you understand and navigate the world around you. So a device like this, it's not just another tool in an astronaut's pocket. It's an integrated part of their mission, a true cognitive extension, something that enhances their senses, their safety, and their ability to explore.
You know, the Helios X1 really shows us what it takes to push our technology to another planet. And in doing so, it reveals the limits of pretty much everything we take for granted today. Which leaves us with one last big question. If this is what it takes to reinvent the phone for Mars, what are we going to have to reinvent next?